Hello class, this video will be an introduction on stoichiometry and how to perform simple stoichiometric calculations. Stoichiometry is a section in chemistry that allows us to determine either the amount of substance in moles, the mass, or volume of reactants involved or products formed. This is useful to know because manufacturers need to know the quantities of raw materials required to synthesize X amounts of product. The most important thing with stoichiometry is that a balanced chemical equation is required so that we can see the stoichiometric relationships between different quantities. From the equation, we can set up the following ratio to find out the amount of unknown substance given we know the exact amounts of one known chemical species. Because we are interested in finding the amounts of moles of unknown reactants or products, we can transpose this equation over here to make this the subject. This can be achieved by multiplying both sides of the equation by the number of moles of known chemicals, which transposes and rearranges equations like this. Let's look at a basic example to see how we can use these mole ratios. In this example, we are given the number of moles of calcium chloride, which is the number of moles of known chemicals, which is the denominator in this case. In part A, I want to find the number of moles of silver nitrate, hence silver nitrate becomes my unknown, which I can then set up using the following ratio. The number 2 and 1 comes from the coefficients in the equation. What I'm going to do now is I'm going to rearrange the equation to make silver nitrate the subject. This is saying that the number of moles of silver nitrate required will be 2 times or double the amount of calcium chloride, and since I know that I have 10 moles of calcium chloride, I can substitute that in. Therefore, the number of moles of silver nitrate reacted is 20 moles. In part B, we are trying to find the number of moles of silver chloride produced from 10 moles of calcium chloride, so silver chloride is also my unknown, written as the numerator. Similarly with part A, the number of moles of silver chloride will be 2 times the number of moles of calcium chloride, which will also give me 20 moles as an answer. For part C, calcium nitrate is the unknown, so we write it as the numerator. Based on the chemical equation, there's a 1-to-1 ratio between calcium nitrate and calcium chloride. Hence, the amount of calcium nitrate produced from 10 moles of calcium chloride is also going to be 10 moles. Now it's your turn to have a go. Pause the video now and give yourself a minute to see if you can answer parts A, B and C. Resume again once you're ready to review your answers. In part A, we want to find out the number of moles of oxygen gas reacted. According to the stoichiometric ratios, the ratio of oxygen to iron sulfide is 7:4. Since we know that there are 2.5 moles of iron sulfide, multiplying 7/4 with 2.5 moles gives the number of moles of oxygen gas required, which is 4.375 moles. In part B, the ratio of iron 3 oxide to iron sulfide is 2:4, which is in other words half. Hence, the amount of iron oxide produced should be half the number of moles of iron sulfide used, giving us an answer of 1.25 moles. Lastly, for part C, the ratio of sulfur dioxide to iron sulfide is 4:4, in other words 1:1. Hence, if 2.5 moles of iron sulfide was used up, then 2.5 moles of sulfur dioxide is also produced. Test yourself again with another similar problem. Pause the video now and resume again when you're ready to compare answers. In part A, the amount of phosphoric acid to mercury to hydroxide is in a 2:3 ratio. Since we know there is 1.4 times 10 to the power of -3 moles of HgOH2, multiplying both values will give us the number of moles of phosphoric acid used, which is 9.33 times 10 to the power of -4 moles. In part B, the amount of mercury 2 phosphate produced will be 1/3 of the number of moles of mercury 2 hydroxide used up, which is 4.67 times 10 to the -4 moles. And finally, the ratio of water to mercury 2 hydroxide is 6:3, in other words 2:1. Hence, the amount of water produced will be double the amount of mercury 2 hydroxide used up, which gives us an answer of 2.8 times 10 to the power of -3 moles. In the second section of this video, we're going to be looking at mass-to-mass stoichiometry. As the name suggests, mass-to-mass stoichiometry involves using the mass of one substance to eventually find the mass of another material. However, we cannot use ratios to convert the mass of one substance to the mass of another substance directly. Instead, we need to first convert the mass of the known reactant to moles using the formula the number of moles equals to mass divided by molar mass, and then we can use mole ratios to find the number of moles of product formed. From there, we can then calculate the mass of product formed using the formula mass equals to moles times molar mass. I would like to add that this process is interchangeable. So instead of given the mass of reactants, we could be given the mass of a product instead, and then we can then work out what is the mass of reactants that's required for this particular chemical reaction. In this video, we're going to be looking at two examples. In example 1, we've got a solution of potassium iodide mixed with lead 2 nitrate to produce the precipitate lead 2 iodide. The question wants us to find out what is the mass of potassium iodide required to produce this precipitate. To begin any stoichiometric problems, I need to have a balanced chemical equation to refer to. In this example, I don't have one, so the first task is for us to write down a chemical equation and work out what the products are going to be. In order for me to identify the products of this reaction, I need to understand that a precipitation reaction is an example of a double displacement reaction. And what that means is that the ions in the reactants are going to dissociate and exchange their partners. So this means that potassium is going to pair up with nitrate and lead is going to pair up with iodide. And therefore, it will form these products. Once I've worked out what the products are going to be, I'm now going to balance my chemical equation. From here, I'm going to start the process off by converting the mass of lead 2 iodide into moles by dividing it by its respective molar mass. This will give me an answer of 0.003167 moles. The next step is for me to find out what is the number of moles of potassium iodide, and I can achieve this by setting up the following mole ratios. According to this ratio, it's saying that the number of moles of potassium iodide will be 2 times the number of moles of lead iodide. Therefore, the answer will be equal to 0.006334 moles. Finally, I can calculate the mass of potassium iodide by multiplying this answer over here by the molar mass, giving me this as the answer. However, we're not done yet. In order for us to answer this successfully, we need to make sure that our final answer for this question has the same number of significant figures as the number of significant figures provided to us in the question. In this example, it's going to be 3 significant figures. So if I was to convert this into 3 significant figures, our final answer is going to be equal to 1.05 grams. Let's look at another example. In the second example, it reads a reaction between solutions of sodium sulfate and barium nitrate produces a precipitate of barium sulfate with a mass of 2.440 grams. Calculate the mass of sodium sulfate required to produce this precipitate. Like the other example, I'm going to write down a chemical equation and work out what the products are going to be. In this particular example, I recognize that sodium is going to pair up with nitrate and barium is going to pair up with sulfate, forming these products. Now I'm going to balance my chemical equation. From here, I'm going to use the mass of barium sulfate to find out the number of moles by dividing it by its respective molar mass. After I've done that, I'm going to now find out what is the number of moles of sodium sulfate by setting up a mole ratio. Because the mole ratio is 1 to 1, the number of moles of sodium sulfate will also be identical to barium sulfate. From here, I can now calculate the mass by multiplying it by its molar mass. This will give me an answer of 1.4855 grams. However, because the question has 4 significant figures, I'm going to need to change my answer accordingly. So therefore, our final answer is going to be 1.486 grams. It's time for you to check for your understanding. Please pause the video now and give yourself 3 to 5 minutes to answer this question. Resume the video again when you're ready to compare your answer. The first thing that we're going to do is I'm going to write down a chemical equation and establish what the products are, and then balance the chemical equation. Afterwards, I'm going to then use the mass of magnesium hydroxide and convert it to the number of moles by dividing it by its molar mass. Once I've done this, I'm going to now set up mole ratios so that I can find out what is the number of moles of sodium hydroxide. According to this ratio, the number of moles of sodium hydroxide should be double the amount of the number of moles of magnesium hydroxide. Hence, the number of moles of sodium hydroxide is going to be equal to 0.26765 moles. From here, I can then calculate the mass of sodium hydroxide by multiplying by the molar mass of sodium hydroxide, giving me an answer of 10.6 706 grams. However, I need to express my answer using 4 significant figures, giving me an overall answer of 10.71 grams. Have a go at the next question. Pause the video now and see if you can get the final answer. In order to answer this question successfully, you need to calculate both the mass of carbon dioxide as well as the mass of steam. So the first thing I want to do is I'm going to calculate what is the number of moles of propane that is present in this reaction, giving me an answer of 0.7773 moles. From here, I'm going to next calculate what is the number of moles of carbon dioxide by setting mole ratios. The number of moles of carbon dioxide should be 3 times the number of moles of propane, giving me an answer of 2.332 moles, and then I'm going to calculate the mass by multiplying it by the molar mass of carbon dioxide, which is equal to 44. Once I've calculated the mass of carbon dioxide produced, I'm now going to find out what is the mass of steam produced by setting mole ratios for water. The number of moles of water produced or steam produced will be 4 times the number of moles of propane gas reacted or used up, which is going to give me an answer of 3.109 moles. Once I've got the number of moles of steam, I'm going to calculate the mass by multiplying by the molar mass of water, which is 18, giving me an answer of 55.96 grams. In order for me to answer this question, I need to add these two numbers over here together, and this will give me an answer of 158.56 grams, but I also need to make sure that I've got the appropriate number of significant figures, which in this case should be 3, hence our overall answer is going to be equal to 159 grams. What I'd like you to do for the remainder of today's lesson to get further practice is to answer the following questions at the back of your worksheet. Thank you for watching this video, and please let me know through email if you've got any questions. Thank you for watching, and I'll see you guys again in the next one. Bye.